Let's look at problem 15. A bargain table has 40 books. 10 are romance, 10 are biographies, 10 are crafts, 10 are historical fiction. If 2 books are selected at random, what is the probability that they are A, the same kind, and then what's the probability that B, they are different kinds? So we're choosing 2 books. And we want to know what's the probability that they are the same kind. Well, that would mean that's the probability that we got 2 romance, or 2 biography, or 2 craft, or 2 historical fiction, right? Because that's what the combinations would be if we had 2 of the same kind. It would have had to either been 2 romance, 2 biography, 2 craft, or 2 historical fiction. So this is our probability, so it's going to be a sum of a number of different counts. And each of these counts, since we're taking 2, we're taking 2 out of, in this case, 10. They made it kind of easy for us. They're all the same, they had all the same number of each kind of book. The number of ways we could get 2 of the romance books would be a combination of 10 taken 2 at a time. Number of ways we could get 2 of the biographies would be a combination of 10 taken 2 at a time, plus combination of 10 taken 2 at a time, plus combination of 10 taken 2 at a time for the 2 craft and the 2 historical fiction. So it's either going to happen like this, or like this, or like this, or like this. So it's the sum of all those different ways, divided by the total number of outcomes when you choose 2 books out of 40. So that would be a combination of 40 taken 2 at a time. And if we were to expand, actually we have 4 of those, don't we? So couldn't we say it's 4 times a combination of 10 taken 2 at a time over a combination of 40 taken 2 at a time? Which would be equal to 4 times a permutation of 10 taken 2 at a time over 2 factorial over permutation of 40 taken 2 at a time over 2 factorial. And if we expanded out all that arithmetic, the answer we would get is, as a decimal, ends up being 0.231. So roughly 23% of the time, we would expect to pull out 2 books that were of the same kind, either 2 romance, 2 biographies, 2 craft, 2 historical fiction. So that's the probability that we get 2 books the same. Now, what's going to be the probability that we would get 2 books that are different? Well, isn't that just the opposite of getting 2 books that are the same? And aren't those the only 2 things that could happen? You would either get 2 books, if you picked out 2 books, you would either get 2 books that were the same, or you'd get 2 books that were different. So if this is the probability of getting 2 books that are the same, the total probability is 1, so the probability that you would get 2 books that are different would be 1 minus the probability of getting 2 books that were the same. So the probability of getting 2 books that would be different would be 0.769, or roughly 77% of the time you would expect to pull out 2 books that were different if you chose 2 out of the 40 that are here.